All right. Good morning, everybody. So we were talking about the comparable interface in the last class. And we were implementing comparable for the point class. Right? Now remember we said that for the point class, we're going to say that a point is less than another point if it's closer to the origin. Right? So P compared to Q returns less than 0 if P is closer to the origin than Q. Right? So you want to implement the comparable interface when you have a class where it makes sense, where that you can sort objects of the class into some kind of order. Right? So for the point class, we've decided that we're going to sort points by their distance to the origin, which is fine. You might sort them some other way. The notebooks tells you 3 or 4 other ways you could sort points. Right? There's lots of different ways you can sort points. When you implement the interface, you have to say that you implement the interface. Right? And then you have to provide this method called compareTo. Right? Now for the point class, it's easy to implement compareTo. You just compute the distance from the origin of this point, right, which we do with hypot. And you compute the distance to the origin with the other point, which again you do with hypot. And then you just compare those two distances, and you can always do that using the compare method from one of the wrapper classes. Right? So if you compute some primitive value here, whatever value you're going to compare with, there's always a primitive wrapper class method that will do the comparison for you. Right? So here we're using double compare because we have two distances that are represented as doubles. Now, if you go and look in the comparable interface, there's a very formal contract when you read the documentation. So let's go there. Okay, so here's the comparable here's the interface here's the documentation for the comparable interface. Right? You can see. Right, now notice that this is the documentation from the Java standard library. So every class in the standard library that implements comparable is listed here, and you can see there's a lot of them. Right? So this is a useful interface to implement in many cases. Now, if you go and read the documentation, it's surprisingly long for something that looks that's not very hard to understand. Right? So it talks about consistency here, which I'll tell you about in a moment. But if you go down to here to the actual method, right, it tells you there's a whole bunch of things that you have to make sure are true when you implement this method. Right, so the first part here is, so SGN is the sign function. So that's, the sign function is this. So it returns -1 if the value of x is less than 0. It returns 0 if the value of x is 0. And it returns 1 if the value of x is greater than 0. Right? So it just tells you the sign of the number. Right? Now if you read the documentation, it says that the sign of x compared to y must be equal to the negative of the sign of y compared to x. Right? So if you switch the order that you're comparing things, then their ordering changes. Right? If x is less than y, then it must be the case that y is greater than x. Right? That's what that's trying to tell you. That's what that part there is trying to tell you in a very formal way. Right? compareTo has to be transitive as well. Right? So it says here, if x compared to y is greater than 0, and y compared to z is greater than 0, that means your implementation must make sure that x compared to z is also greater than 0. Right? So translating that into math, right? If x is greater than y and y is greater than z, then it must be the case that x is greater than z. Right? And then finally, one last thing, x compared to y equals 0. Right? That means that the sign of x compared to z must be the same as the sign of y compared to z. Right? So that's basically saying that objects must agree on their comparability when you compare them. Right? So if x and y are quote unquote equal, right, then x compared to z must be returned the same sign as y compared to z. Right? So in other words, x and y must agree on how they compare to z. Right? And then the rest of the part I'm going to tell you about next. Okay, so there's something called consistency with equals. compareTo is said to be consistent with equals when the following two conditions are true. Okay? So if x compared to y returns 0, then x equals y returns true. Right? And if x equals y returns true, then x compared to y returns 0. Right? You should know from your math classes that that's basically if and only if. Right? So if and only if x compared to y returns to 0, then x equals y is true. Right? So this is the way compareTo normally behaves. Right? So for most classes that you implement, compareTo will be consistent with equals. Right? Basically, this is saying that right, if x and y are equal, then x compared to y should also say that they're quote unquote equal. Right? They should return 0. Sorry, if x equals y is equal, so if x and y are equal, then x compared to y should return 0. Right? Up here it's saying if x compared to y is 0, then x equals y should be true. Right? So that's what it means by consistency. Right? So whenever compareTo returns 0, x equals y is also true. Right? And vice versa. It's not required that that be the case. Okay? So you can come up with situations where it makes sense, right? Where x compared to y returns 0. Right? So as far as compareTo is concerned, the objects are equal when you compare them. Right? But x equals y is false. So as far as equals is concerned, the two objects are not equal. Right? And similarly, you can come up with situations where it makes sense that x equals y is true. Right? So two objects think that they're equal. But when you compare them, they're not equal. Right? So that sounds a bit weird. Right? You should try to cook up some cases, some examples for both of these cases here. The first one's easy. The second one is quite unusual. The first one, so for example, the point2 compareTo method, it's not consistent with equals. Right? So remember how our point2 comparison method works? Right? It looks at the distance between 2 points. Right? So it looks at the distance between a point and the origin. Right? So I can have the point 1, 0, right? So 1 unit along the x-axis, right? And I can have the point minus 1, 0, so the point on the other side of the y-axis, right? They have the same distance to the origin, so x compared to y is going to return 0, right? But they have different coordinates, so x equals y is going to return false. Right? And you can come up with lots of situations where the first case here is true. Right? And I'll let you think about the second case on your own. So when you go to implement compareTo, right? So I showed you how to use double compare, right? If you're comparing two quantities that are float or double, so if they're floating point type, you really should use double compare instead of less than, greater than, or equal to. Right? Because double compare guarantees that the comparison works in a consistent way. Floating point's weird, so less than, greater than, and equal to is unusual for certain values, for certain floating point values. Right? If you use the double compare method, you always get the same comparison. Right? So in other words, you get consistent results. Okay, now it's easy to implement compareTo. It's also easy to implement a bad version of compareTo, so an incorrect version of compareTo. Right? Now the problem is if you implement an incorrect version of compareTo, right, a whole bunch of things start to break. Right? So for example, if you try to put your objects into a tree set, suddenly you get strange behavior. Right? Similarly, if you try to put them into a tree map, again, you get strange behavior. Why? Because these two things sort their collection of objects. Right? And how do you sort? Well, you compare objects. Right? That's how all the sorting algorithms that we've shown you work. Right? There's some sort of comparison between two different objects. Right? Tree set and tree map both use compareTo to compare objects. So if you provide an object that has a bad implementation of compareTo, suddenly tree set and tree map can't satisfy their contracts. Right? Similarly, any method that relies on sorting or having a sorted collection, suddenly those methods stop to work as well. Right? So for example, binary search, right, will compare two objects. How does it do it? It uses compareTo, right? Because it needs to know whether to search the left-hand side or the right-hand side of the list or array. Right? all the sorting methods are also broken, right? So collections.sort and list.sort, now they start to fail. Right? So if you're ever in a situation where you see a sorting method fail, the first place to look is the compareTo method for the objects that you're comparing. Okay, so what about the counter class? Remember the counter class, it's just counting some number. It's just an integer, right? So it counts up to some value, right? Now sometimes when you implement compareTo, the value that you return might encode some useful information, right? So that's the case for string, in fact, right? So if you look at the string class and you go and look at its compareTo method, it'll actually tell you that the information returned by compareTo is useful in some way, right? You can also make the information useful for the return value useful for the counter class, right? So I want to implement comparable for the counter class. So class counter implements comparable counter, right? So I can compare two counters. I've written the contract for my compareTo method here, right? It says when I compare counters, I'm going to compare their values, which makes sense, right? So a count of 5 is greater than a count of 2, right? Now you might want to know what's the difference between the two counts, right? So compareTo returns the difference between the two counts, right? Which might be useful in some circumstances, right? So how do you implement that? Now remember, compareTo has to return minus a negative integer, 0, or a positive integer, right? So you can write compareTo in this case as this value minus other value, right? And why does this work? Because if the values are the same, right? The values are the same, then compareTo returns 0, which is good, right? The two counters are equal. If this value is less than the other value, compareTo returns a negative value, which is also good, right? That's what we want. If the value of this counter is greater than the value of the other counter, then compareTo returns a positive value, which is also good because that's what we want as well, right? Now you have to be very careful when you write this, right? So so I told you just a few slides ago that when you're comparing two primitive values, it's always a good idea to use the compare method from the wrapper class, right? And here I'm breaking that rule, right? Because I want to return some information that's useful. When you break the rule, you have to make sure that what you've done always works, right? And so you have to ask yourself the question, does this always work for two counters, right? And so when would this not work? So it always works for the counter class. But if that's an int and that's an int, it's not guaranteed to work, right? Because you're doing arithmetic with an int, and that can overflow, right? If that overflows, you get the wrong sign on the answer, and that's not good, right? Here, I know that it can't overflow, right? And why do I know it can't overflow? Because the counter values are restricted to be always non-negative, right? So they're always between 0 and integer max value. Right, so no matter what values I plug in for this value and other value, when I do this difference, there will not be integer overflow. Right? If the two values could have any integer value, then you can't write that and have this work correctly. Okay? So you have to be very careful when you write this. It happens to work for the counter class only because the counter has an invariant that says that the value is greater than or equal to 0. All right, so that's compareTo. I would like to go home, but I'm not going to. All right, next slide. Next set of slides. Where are we here? Enumerated types. All right. Okay, so the next topic is enumerated types. Right now, so enumerated types are what are they? They're uncommon. Nah, they're not super common. But they are useful in many circumstances. Okay, so I've got a bunch of examples here. So I've got days of the week, months of the year, the suits in a standard deck of playing cards, right? So hearts, diamonds, clubs, and what did I miss? Spades, right? The ranks of the standard playing cards, right? So 2 through 10, Jack, Queen, King, Ace, right? Canadian coins, provinces and territories, planets of the solar system, arithmetic operations, right? These all have something in common, right? What do they have in common? There's only a small-ish number of values that any of these things can have, right? And they're constant, right? So the days of the week, well, there's 7 days of the week, and they all have well-known names, right? 12 months in the year, they all have well-known names, right? The suits, there's only 4, right? So on and so on and so forth, right? So all of these things represent a relatively small set of constant values, right? Some of these are some of these are better examples than others. So for example, Canadian coins, right? For the most part, right, Canadian coins, the set of Canadian coins is constant, right? So right now there's a penny, there's a dime, quarter, loonie, toonie, right? But there's nothing from stopping the Canadian government from taking away coins or adding coins, right? So we took away the penny recently, right? You shouldn't be surprised if there's a $5 coin that's introduced sometime in the future, right? So this may not be the best example of an enumerated type. So an enumerated type, it's often called an enum type or just enum, is a type whose values consist of a fixed set of constants, right? So this is important. It's fixed, right? And the values that are represented are constant, okay? So their values never change, right? So if you go back through those examples, you can easily write down what the fixed set of constants are, right? Okay, so older Java code and C code, so the language that Java basically inherited from, there's no proper enumerated type. So what you used to do is you used to make what are called int enums, right? So you use an integer value to represent each enumerated constant, right? So for example, in old style Java, you would write public static final int, so that makes a constant, right? Sunday is 0, right? And then you'd write public static final int Monday is 1, and so on and so on and so forth, right? If you wanted the months, you would do the same thing, right? You do public static final int January, and that's 0, right? And then public static final int February, and that's 1, right? And if you're awake, you can see that there's immediately a problem, right? Sunday and January are equal. So that's a bit weird, right? So now someone can write down code that says if Sunday equals January, do something, right? And that works because they're ints, right? That's a problem, right? So when you use ints to represent enums, there's no what we call type safety, right? Any method with an int parameter will accept a day or a month, right? So for example, I can take the absolute value of a day, right? I can take the square root of a month, right? And it works just fine, which is strange, but it works, right? You can, if you make a method where you want to accept only a day, right? There's no way to restrict the parameter to be only a day, right? Because it has to take in an int, right? The type here is an int. Right? So the type is an int. So when you write your method, it's going to have a parameter whose type is int, right? Even though the intent is to only pass in days, right? You can do weird things like perform arithmetic, right? So I can take January plus April or something like that, right? And then you can compare days and months. Now that's not so bad. So that you might actually want to do that, right? So you actually might want to say, well, Sunday comes before Monday, right? And so comparing things is not so bad. There's another problem when you use ints, right? There's no way to translate the constant into a string in a nice way, right? So there's no toString method for ints, for example, right? So for example, if I wanted to print out, right? If I wanted to say system.out.println Sunday, you get the number 0, you don't get the word Sunday, right? If you want to translate it to a string, you've got to write a method that translates it to a string. Now, there's another common way to do this, right? So again, prior to, I can't remember which version of Java introduced enums. But anyway, you don't have to use ints. You can use any type or any immutable type to represent a constant. So another common thing was to use strings, right? So instead of saying Sunday is 1, I'm going to say Sunday is the string, all caps, Sunday, right? And so on and so on and so forth. Right, so this is called the string enum pattern, right, which is also quite common, or was common in Java, still common in C, but it has problems too, right? So that's not much better than using an int, right? So all of your enumerations are now strings, so there's still no type safety, right? There's no difference between Sunday and January, right? They're both strings. They have different, right? They have different, their constants are different, but there's no difference in their type. Yeah?
Writing out those strings, what would be the advantage of writing public static final as opposed to just writing strings?
So instead of writing just string Sunday, so if you make it public and you write public string Sunday equals Sunday, right? Somebody else can come along and say Sunday now equals Tuesday and change this and change what the reference equals. Right? When you make it static, when you make it final, right? Final means you can only assign a value to it once. Right? So I assign a value to it once and that's it. Now the word Sunday, now the string capital all caps Sunday is always that string Sunday. Yeah. You also want to make it static because you're going to put it into a class, right? And you don't want every object to have its own copy of Sunday, right? Because there's no point. It's a constant, so there's no point to having every object have its own copy. Okay. Right, so problem number one, there's still no type safety, right? There's still no type called day, there's still no type called month, or whatever other enumeration you want to make, right? What ends up happening a lot when you use the string enum pattern is that people don't use your constants, right? So in other words, people don't write month.Sunday, they just get used to writing the string Sunday, right? Which is also not good, right? You really want them to be using your constants, right? Now another problem, a bigger problem is the reason for using enumerations is because you want to check if two things are equal, right? I want to know is the month January, right? Or I want to know is the day, is the month day, is the day Tuesday, right? But that means I'm going to use equals to do the comparison, right? Checking strings for equality is way slower than using ints or addresses, right? To compare two strings, I have to compare every letter of the string, right? Whereas comparing two ints is very fast. Okay, I guess it's Java 1.5 where we got enumerations, right? So Java 1.5, so that's version 5 of the language, added an enumerated type, right? So it's enumerations now become what are called first-class classes, right? So they actually become proper classes. It turns out that the way they introduced the enumerated type is they made a type called big E enum, right? And whenever you make your own enumerated type, the compiler knows to silently extend that class there, right? So we're going to talk more about inheritance and extending classes in about a week or so, right? But for now, all of your enumerations have that type. Because enumerations are proper classes in Java, right? They can have fields, so you can put information into an enumeration now. And you can put methods into an enumeration, right? And so this turns out to be very powerful, right? Now your months and days can do things, right? Instead of just being ints or strings. So enumerations are supposed to be constants, right? It's supposed to be a constant set of values. So it doesn't make sense that there's a constructor. Right? It doesn't make sense that you let someone make an enumerated object, an instance of an enumerated object, right? Because it's just supposed to be a bunch of constants. So you don't want a whole bunch of objects of your enumerated type. But if the enumeration has fields, right? So if the enumeration store information, then they need a constructor, right? So you can have a constructor in an enumeration, but the constructors are all private, right? So in other words, you can only set the values of the fields of the enumerated types of the objects when you create the enumeration. So I'll show you how that works in a second. Okay, so enumerations are really easy. So to make the enumeration day, that's all you have to write, and you're done. Right? You don't have to say Sunday equals anything. You don't have to say Monday equals anything. You just write down the constants that you want, and that's it. Right? You just give them a name. Right? So it's public enum, the name of your enumerated type, right? And then all of your enumerated types separated by commas inside of a set of braces, right? And you now have a fully functioning enumerated type, right? So this makes a type called day, right? So your days are now days. They're not strings. They're not ints, right? How do you use it? Well, the type, that day, all these things here, they're just they're fields of the enumeration. So they're just constant fields of the enumeration, right? So to get the day Thursday, you just write day.Thursday, and away you go, right? You can print out the day, right? And you get the name of the enumeration, right? So you actually get the string Thursday, which is nice, right? If you were using ints, you'd have to call some method to translate the int into a day, and then print out that result. Right? Here the enumeration does it for you for free. Right? So what's happening here is, well, the compiler has generated a toString method that produces that string. Right? And it's silently done that for you. If you want to, you can override it. So you can change the way your enumerations get printed if you want to. All right, so here's the important part. Now remember, your an enumeration represents a finite set of constant objects, right? Or constant values. So it doesn't make sense that you have more than one of each constant, right? Because everything's constant, so it doesn't make sense that you have more than one of them, right? A Java enumeration guarantees that there's exactly one instance of every constant in your enumeration, right? So Java guarantees there's only one thing called day.Sunday. There's only one object called day.Monday. There's only one object called day.Saturday, right? Only one, and it's guaranteed, right? So what does that mean, right? So if I want to compare enumerations, right, I don't have to use dot equals, right? I can use equals equals or not equals, right? Because remember, equals equals and not equals, those are checking for equality of identity, right? Do two things represent the same object, right? Well, if there's only one thing called Sunday, right, then Sunday is only equal to Sunday, right? It's only equal to the object Sunday, right? Monday is only equal to the object Monday, and so on and so on and so forth, right? So when you compare enumerated types, you can use equals equals and not equals without worry, right? I don't have to call equals. I don't have to write exclamation mark d dot equals something, right? Because there are no accessible constructors, right, there's no way for somebody else to make another day, another object of type day, right? There's no constructor, so they can't make any more objects. Well, there's no public constructor, right? So that means equals equals and not equals always works. Enumerations are proper types, right? So they're actually classes, so it's a proper type. And that means you get all the benefits of compile time type safety, right? So now I've got the enumeration called month. Back here, I've got the enumeration called day, right? Oh, wait, what happened? There's a slide. Oh, sorry. Right, so suppose you have a second enumerated type, right? Now before, when I was using an int, right, January would be 0, Sunday would be 0, right? And they would both be ints. So there's no way I can stop any method that takes an int from accepting a month or a day, right? But now you can write a method that takes in a month, right? A big M month, right? And it will only accept one of these objects that are listed in the enumeration, right? You can write a method that only takes in a big D day, and it will only take in one of those objects. If you try to pass it anything else, the compiler will tell you that's not a month or a day, right? Okay. So the int enum pattern lets you compare integer enumerations, right? And so it turns out that sometimes you really want to compare enumerated types for order. Yeah, sorry.
I was just wondering, when we put in the days of the example,
Yeah.
does that have to be capitalized?
Does what have to be capitalized? So the language says no, but convention says yes, because these are constants. Constants are always all caps. Yeah. But if you wrote,
It wouldn't matter if you
Now, the compiler wouldn't care. The compiler doesn't care. Other Java programmers might complain. Yeah. Okay, so sometimes you really want to compare your instances of your enumerated type, right? So it makes sense to compare months. It makes sense to compare days, right? It doesn't make sense to compare all enumerated types, but sometimes it does, right? So enumerations automatically give you you get a compareTo method that's generated by the compiler, right? So the natural ordering for an enumeration is the order in which you list your types. The order in which you list your constants, right? The one drawback with the Java enumerations is there's no way to change that ordering. So once you write your constants in a fixed order, that's the order that they're going to compare, right? So let me go back to the other one because it's shorter. Here we go. Okay, so when I write down that ordering of days, right, as far as the day version of compareTo is concerned, Sunday comes before Monday, Monday comes before Tuesday, Friday comes before Saturday, right? Which is fine in North America. Some countries start the week on Monday, right? So in some places, Monday is the first day of the week, right? And Sunday is the last day of the week, right? So now if you give them this enumeration, they're going to say, well, that's weird, right? Because in my country, Sunday comes after Saturday, right? And in this enumeration, Sunday comes before, Sunday is the first day of the week, right? So that's one of the drawbacks of Java enumerations. You get compareTo for free, but you can't change the way compareTo works. Right? So for example, I've got Monday, Thursday, and Saturday. Right? So if I write D1 compared to D2, right? So that's Monday compared to Thursday, right? You get -3, right? So Monday comes before Thursday, right? D3 compared to D1, so that's Saturday and Monday. So Saturday comes after, right? Monday. D2 compared to D2 is Thursday compared to Thursday, so that returns 0, which says that Thursday is equal to Thursday, right? The value that you get from compareTo is the difference in the ordering of the two elements, right? So D1 compared to D2, so that's Monday and Thursday, right? So here's Monday, here's Thursday, so 1, 2, 3, right? Or -3 in this case. Right, so it gives you back the difference in their ordering. Okay, enums can have fields, right? Because an enum is a class, right? So you can give your enumeration, your constants information, which occasionally turns out to be very useful, right? Now, in order to set the value of the fields, you want to call a constructor, right? Because that's how you set the value of fields for any class, right? Now, your constructors are private, right? So the way you call the constructor is a bit weird when you write an enumeration. Okay, so this is how you write an enumeration if you want to give your constants some information, right? So here I've got the month enumeration. I've now changed it a little bit, right? I'm also going to add this field called days to my enumeration, right? It's marked final. It's marked final for a good reason, right? So remember what final means when you on a variable. Final means you can only give that variable a value once, right? And that's true whether it's a variable or a field, right? Or a constant. So I'm going to mark days as being final, which means I can only ever give the value days I can only ever give days a value once, right? I'm going to do it in the constructor. The way you call the constructor is beside the constant name, you write some brackets, and then you pass in the argument to the constructor, right? Whatever arguments you have, right? And so here I'm passing in the number of days for each month, right? Now on the next slide, I'm going to show you the constructor, right? So here's the constructor for the month enumeration, right? It has all the same rules as a constructor for any other class, right? The name of the constructor is the name of the enumeration, right? It can have parameters if you want. If it doesn't have parameters, that's fine too, right? So you can put in a no argument constructor if you like, right? You can put in it doesn't make sense to put in a copy constructor, but any other constructor is fine, right? Notice there's no access modifier in front of month, right? So there's no public, well, there's definitely no public. So the constructors are always private, right? If you try to put anything other than private or nothing, right, the compiler will not compile your enumeration, right? It will tell you that the constructor is supposed to be private, right? So you can put in private if you want to. You don't have to. But you cannot put in public, and you cannot put in protected, right? So no access modifier. It's implicitly private, right? The constructor doesn't do anything here. It just sets the value of days, right? So that's fine. So here I make sure to pass in the right number of days. Now, February is weird, right? Because in a leap year, February has 29 days, right? Now, if I've given the enumeration some information, right? So every enumerated constant has some information. Whoever's using the enumeration probably wants to get that information out somehow, right? So you can add a method to your enumeration, or methods, right? Again, because an enumeration is just a class, right? So I can provide a method called days that returns the number of days in any month, right? In order to compute the correct number of days, I need to know the year, because February is weird, right? February is the month that contains the extra day for a leap year, right? Okay, so if the month is not February, then I can just return the value of days, right? Otherwise, I have to check, is it a leap year or not, right? So the definition of a leap year is, well, I guess if you were in lab 3, you know what it is, right? If you don't know what it is, so a year is a leap year if the year is divisible by 400, right? So if it's divisible by 400, it's guaranteed to be a leap year. If it's divisible by 4 and not divisible by 100, it's also a leap year, right? Okay, so 2000 is a leap year because it's divisible by 400. 1900 or 2100 is not a leap year because those are divisible by 100, right? It has to do with how long the day is. So a year is 365 days plus a little bit, right? So the plus a little bit is not exactly one extra day every 4 years, right? It's a little bit different than that. So every 100 years, they say it's not a leap year. Every 400 years, it's a leap year, but otherwise it's not, right? If it's a multiple of 100, right? So if it is a leap year, and it's February, then I add 1 to the day, right? Otherwise, I just return the number of days, right? And so now you've got an enumeration that I can actually provide information about the month. Okay, so whenever you make an enumeration, you get a bunch of methods for free. One of them is called values, right? So the method is static, it's public, called values, and it returns an array of the constants in the order that they were declared. So it returns an array of your enumerated types in the order that they appear, right? So if I call month.values, I get the array January, February, March, April, May, blah, 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 December, right? These aren't strings, right? These are, you actually get, the array actually contains the enumerated constants, right? So you get the day, you get the month January, the month February, the month March, and so on and so on and so forth, right? So if you want to get all of your enumerated constants as an array, you just call values. Here's another example using month. So I'm going to call values here. So it's the same as the previous slide, right? But now I'm going to iterate over the enumerated constants, right? Sometimes this is useful to do too. You want to do something with every constant, right? So you can just write a little loop that loops over the returned array, right? And I can print out the number of days in the year 2018, right? And that prints the following, right? Right, so January has 31 days, February has 28 days, and so on and so on and so on in the year 2018, right? If you change it to 2020, then the February prints out 29, but everything else is the same. Okay, now the other thing that's often useful to do with an enumeration is that you have a string, and you want to convert that string to the enumerated type, right? So for example, if I had the string capital all caps January, it would be nice to be able to get the enumeration month.January, right? And you can do that too. because your enumeration has a method called value of. Right? Again, you get this for free. The compiler generates it for you. Right? So value of returns the constant that corresponds to the argument string. Right? So for example, if I call value of May, right, you get the month May. Right? If you ask, is M equal to the month May, you get true. Right? So you actually get the enumerated constant if you use the value of method. Right? All right, so this one's a little weird. So this one sort of leads into part 3 of the course. Right? So part 3 of the course, we're going to start talking about inheritance. And this is the sort of the first time you're going to see it, but it's shown to you in a very unusual way. So each one of your constants in the enumerated type can have its own version of a method. Right? So back here, where is it? Here. Right? So here I've got a method. Right? But this method is the same for January, February, March, April, May, June, blah, 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 blah. Right? So it's the same for all of them. Right? This slide is telling you each one of your constants can have a different version of that method. Right? So there's a way easier way to implement that method that I showed you there if you do it this way. Right? Now, the way you do this is you declare what's called an abstract method in the enum. So I'm going to show you that in a second. Right? And then every constant overrides that abstract method. So every constant provides its own version of that abstract method. Right? So I'm going to make an enum now where you have 4 different arithmetic operations. Right? So you've got addition, subtraction, division, and multiplication. Right? You might want to do this sort of thing if you're actually implementing a calculator. Right? Because a calculator normally has a finite set, a fixed and finite number of operations that it can perform. Right? So here's an example of an enum that represents 4 operations on a calculator. Right? So my enumeration is called operation. Right? And I've got this constant called plus. So this represents addition. Right? Minus represents subtraction. Times represents multiplication, and divide represents division. Down here, there's a method that's marked abstract. Okay? So public abstract double apply, double xy. Right? So this apply method is going to, for each operation, right, will perform that operation with x and y. Right? So plus apply will add 2 values of x and y and return the sum. Right? Minus apply will compute x minus y. Times apply will compute x times y. And divide apply will compute x divided by y. Right? Now the method's marked abstract. So an abstract method has no body. Okay? So what that line there says is that there's some method called apply that returns a double. Right? But it has no implementation here. Right? Instead, every constant has to provide an implementation of that method. Right? So plus provides a method called apply that returns a double and takes in 2 double values. Right? All it does is add x and y. Right? Minus provides a method called apply that returns a double and takes in 2 double values. Right? So it just computes a difference. And so on. And so on, right? So times and divide, they do exactly what you think they ought to do, right? X times y, x divided by y, right? So now when you write something like plus dot apply, right, you get the sum of the 2 numbers that you pass in, right? Now you don't have to write plus dot apply, right? You can make a variable of type operation, right? So you can make a variable of the enum, right? Let's call it O, right? Somewhere else, someone else provides you one of these types, right? So you can say O equals some method, right, to get one of these operations, right? And then you just write O dot apply, right? You don't actually need to know which one of these operations is being applied, right? Because now your enumeration is a type, right? Which means you can make variables that can store these things. Right? So someone can hand you a variable that stores an operation, and you can just apply that operation. Right? You don't even care what the operation is. Right? because the enumerated type will take care of calling the right method for you. Okay, sorry, I just have to check the time. Oh, all right, so there's only 3 slides left, so let's do this quickly. Sometimes you're going to write a method or a constructor that takes in a Boolean value, because it can have one of 2 values, right? So this is pretty common to do. So Booleans are often used as parameters when there's a choice between 2 different values, right? So here I've got a constructor for the class called binary digit, right? So you know what a binary number is, right? It has all zeros and ones. In this case, this is just 0 or 1, right? So I can use a Boolean to represent the input to the constructor, right? So value is true if I want the binary digit 1, right? It's false if I want the binary digit 0, right? Here I've got a thermometer class, right, that lets you change the units of the temperature, right? So if scale is true, then you get a thermometer that measures things in Celsius. Otherwise, it measures things in Fahrenheit, right? The problem with doing this is that you end up writing stuff like binary digit B equals new binary digit true, or new binary digit false, right? Or thermometer T equals new thermometer true, or new thermometer false. And you have no idea what the true or false is supposed to represent, right? You now have to go and look in the documentation and try to figure out what's going on. If you make an enumeration for the inputs, everything becomes very simple, right? So now, when you read these, you know exactly what's happening, right? You know that the first constructor there is making a binary digit 1. You know that the second one's making a binary digit 0. You know that that thermometer is measuring things in Celsius, and you know that that thermometer is measuring things in Fahrenheit, right? So using enumerations in this way makes your code a lot easier to read. Okay, so when do you use an enum? So they're a little unusual, right? They're unusual because in programming, it's somewhat unusual to have a fixed set of constants, right? Usually when you think something's going to be constant, it's not, right? So the example of Canadian coins is a good example, right? You think, well, there's only a finite set of Canadian coins and they're always the same, but that's not true, right? We just took away the penny a few years ago. There's probably going to be a $5 coin, and there's probably going to be a $10 coin at some point in time. Right? So you have to be a little bit careful about using enumerations. There's no good way to extend an enumeration. So there's no good way to take something away or to add something to an enumeration. Because when you do that, you break everybody else's code that was written before you made the change. Right? So these things are really supposed to represent fixed sets of constants. Okay? So when you have that situation and when you're sure you have that situation, that's an appropriate use of an enumeration. Using enumerations usually makes your code a lot easier to write, and it makes it a lot easier to read. So if you've been looking at the notebooks, you'll know that there's this class called card that represents a playing card. There's two different implementations. One of them uses a string for the rank and the suit, right? The other one uses an enumeration. Oh, I should really stop, but let me just quickly show you what happens. So with the string, right, the problem with making a card with a string, where you specify the rank and the suit, is you've got to check when you make the card, right? You're going to pass in a string for the rank, you're going to pass in a string for the suit, right? But now you have to check, is the rank valid and is the suit valid, right? If you want to change the rank or suit of the card, now you've got to check, is the rank valid or is the suit valid? And this becomes very old very fast, right? Similarly, if I want to get the color of the card, right, I've got to check, what is the suit equal to, right? Is it equal to a diamond or is it equal to a heart, right? And that becomes, again, that becomes very old very fast. If you use an enumeration, you don't have to do any of that. Look, so when I make the card, right, if I pass in a rank object and a suit object, well, I don't have to do anything. I know that the rank is valid. I know that the suit is valid. So I just go ahead and assign the rank and suit. Right? How do I get the color of a card? Well, I just ask the suit for its color. And away you go. Right? So enumerations often make your code, if you can use them, they often make your code a lot easier to write. And they certainly make it a lot easier to understand. Alrighty, so assignment 3 is going to be short because it's a little bit late. But it will come out later today. Okay?